The next test is called limit comparison test. Now this is a very versatile test and is very useful when ak is a rational expression. Rational expression means things like k squared plus 1 over k cubed minus 2k plus 5. When you have ak of this kind of form, then this test is very handy. Okay, so what does this test say? So it says there are two series AK and series BK. They have positive terms, which is always the case, and you take the limit of AK over BK, and suppose the limit is L. Then if L is between 0 and infinity, that means it should not be 0 and it should not be infinity. That means L is a finite positive number. Then the two series converge or diverge together. So that means they go together. Now the other two cases, if L is 0, if that limit was 0 and the series BK converges, then AK converges. If the limit is infinity and BK diverges, then AK diverges. Now these two cases are rare. This is the one that we encounter almost all the time. So again, the series that's given to us is series AK. The one that you have to guess is the series BK. And we must know something about series BK. We should know if it converges or diverges. So there are two things. First, you have to guess the series, and then you have to know whether it converges or diverges. Now that seems like quite a bit of a requirement, but actually it is not, as you will see when we do these examples. So the first one is, I want to study summation n going from 1 to infinity n over 5n squared minus 4. Okay, so my an is n over 5n squared minus 4. So now my turn to guess bn. So I'm going to guess 1 over n. So that means my series bn is series 1 over n, which diverges. So this is my guess. Now why am I guessing this? I'll point out very soon to you why. So with this guess, we have to go and find limit n going to infinity an over bn. So this is what we have to find. So let's find it. So limit n going to infinity, an was n over 5n squared minus 4. Now I'm dividing it by bn, which is 1 over n. So that gives me n squared over 5n squared minus 4. Now this is simple. I'm going to divide the numerator by n squared and the denominator by n squared. So if I do that, then I'm going to get 1 over 5 minus 4 over n squared. Now as n goes to infinity, this guy goes to 1 over 5 minus 0, which is 1 over 5. So this is my L. And clearly L, which is 1/5, is between 0 and infinity. So that's good. So that means by test 1, right here, this test, it says the series AK and the series BK go together. So therefore, since the series BN diverges, remember when we guessed Bn, we knew that it diverges. So since series Bn diverges, that means my series An also diverges. Now somebody might be tempted to think that if I had chosen some other Bn, then I might have gotten a different result, but that's not true. This is the only Bn which comes to a correct conclusion. You can try, but it won't work. Okay, let's try another example. So now I have series n going from 1 to infinity, 3n minus 2 over n cubed minus 2n squared plus 10. So first my guess. So this time I'm going to guess Bn to be 1 over n squared. So therefore, what can I say about my series Bn? Well, series Bn is series 1 over n squared, and this converges because this is two series. Remember from P series we learnt that when P is 2, you get convergence. Now I'm going to find limit An over Bn. So let's do the algebra. 3n minus 2 over n cubed minus 2n squared plus 10. Now this whole thing has to be divided by 1 over n squared. So by flipping the denominator, n squared comes up and we are left with this fraction. Now again, to find the limit, we can divide the numerator and denominator by an appropriate power of n, and in this case n cubed would be a good idea. So if I divide the numerator by n cubed, what are you going to get? 3 minus 2 over n, you can do it, divided by, each term divides by n cubed, so I get 1 minus 2 over n plus 10 over n cubed. Now as n goes to infinity, so as n goes to infinity, I have 3 minus 2 over n, this guy goes to 0, over 1 minus 0 plus 0, so these guys all go to 0. So therefore I'm left with 3. So this is my limit. And clearly this is finite. Therefore the first test tells me that since my series Bn converges, that means my series An also converges. So this is the answer. Okay, so you must be thinking, how can I guess my Bn? Well, here is the idea. So how to choose Bn? So one more example, and then so suppose I make up one example. Suppose the series is n square minus 1 over n to the power 5 plus n squared, suppose. Now by just looking at it, I can tell you that my Bn would be 1 over n cube. So there is a pattern in this. So let's look at all three examples and see if you can guess. So the first one, my An was this, and I selected this as the Bn. So how you think is as follows. Look at the power of the numerator and look at the power of the polynomial in the denominator, and think about what is the net power. So this is power 1 here, and this has the power 2. So the net power is 1 over n. So the 1 here, 2 here, so the net is 1, n. Now this power is 1. Let's go to the next one. So here I had this, so the power of the numerator was 1, the power of the denominator was 3. So if it is 1 here and 3 here, so the net power is 2. So that's why I guessed Bn would be 1 over n squared. Now in this one that I just made up, the power is 2 of this polynomial, the power of this polynomial is 5. So 5 minus 2 is 3. So I'll take 1 over n cube. So I'll take a polynomial with power 3. So that's how it works. Now suppose I am doing this one. So let me just tell you, An is 1 over radical n squared plus 9n. So my Bn would be, so what's the net power of An here? This is 0 power and this is 1, because radical of n squared plus 9n has power 1. So I will use 1 over n. And we know series Bn diverges. So let's try our luck with An over Bn. What do we get? Well, it's just a matter of algebra. It's 1 over radical n squared plus 9n. Now divided by 1 over n. So that means you get n in the numerator. So now you're going to divide numerator and denominator by n. So you get 1 over radical n squared plus 9n. divided by n. Now if you want to bring the division inside the radical, this becomes radical n squared plus 9n divided by n squared. Now notice that the n has come inside the radical, okay? So this leaves me with 1 over radical 1 plus 9 over n, and as n goes to infinity, I get 1 over radical 1, because 9 over n is going to 0. So therefore this is 1, which is very nice. So therefore the series AN diverges because series BN was diverging. So it's just a matter of algebra to find these limits, and these turns out to be a very, very useful test.